everyone. Thanks for your patience. Today, it's my pleasure to host the fourth session of Azure Partner Fest, organized by Microsoft Singapore. We started earlier this month, and we will have a total of 7 sessions all the way to mid-April. So if you haven't done so, I encourage you to register for the upcoming sessions, including next week's sessions on Vim solution to back up your Kubernetes workload and address the challenges around business continuity, disaster recovery with containers. Right. Before we start today's session, let me go through housekeeping rule. Right. So today's session will be recorded and will be eventually available online on our YouTube channels. Please use the Q&A panels to ask your questions at any point of time. We will have 10 minutes at the end of the presentation to address all of them. Right. Back to our topic of the day, let me introduce our great partner, HashiCorp. When we talk about automation, and especially when we talk about cloud automation, HashiCorp is definitely among the industry leader. We often hear about infrastructure as code, sometimes compliance as code. And in these sessions, we will see how to combine the speed of deployment together with security. Right? And for that, we are honored to have 2 speakers today. David, you are the solution engineering lead from HashiCorp and joining us from Sydney. And Jason, cloud solution architect, at Microsoft Singapore. Thanks a lot for being with us today. It's really a pleasure. And to be honest, as a Azure user myself, I'm always looking at more agility and flexibility. So I'm very excited to learn how I can better automate all my deployments in a secured manner. Thanks both. The applause is yours.
Thank you, Francois. So like what you clearly point out, I mean, I was a developer previously as well, right? So I just want to share some context before I hand over the floor to David, right, to set some context. I think traditionally in application development, at least during my developer days, security testing and whatever testing tends to be bolted at the end of a project, right? And this, we all know, often leads to delays due to the need to go back and forth between the various teams, be it infra team, application team, security team, to rectify the issues in order to get it retested, and finally we go live with the project and the system, right? I think this waterfall model approach of application development might have served us well in the past. But frankly speaking, it can no longer meet today's needs, right? I think nowadays, every company wants to become an agile software company. And the ability to execute a DevOps model is essential in order to deliver better applications faster and cheaper. I think the keyword is faster and cheaper, right? With the right tooling, I think we can allow different participants, be it application team, infra team, security team, be it development, operations, and security, to focus on their primary concerns while unblocking the peers. We don't want to be the bottleneck of each other, right? So coupled with today's need, right, when companies transition from on-prem to cloud, it actually introduces new challenges, especially from the enterprise security standpoint. There are more systems to manage, more endpoints to monitor, more networks to connect to, and last but not least, more people needed access. Right, the potential of a breach actually increases significantly, right? So it's just a matter of time. If you do not have the right security posture, a breach will happen. Right. So in today's session, David, with his extensive experience and knowledge, will be sharing how HashiCorp, together with Microsoft, can help you shift left and think security early in the development life cycles to reduce risk and cost while improving productivity. Right. So I just want to set some context before we went to today's session. So without further ado, I will hand over the stage to David. David, please take us through.
Thank you. I'm now concerned because you called me an expert, and I would never consider myself that at all. So that's a worrying precedent. Just to introduce myself, I am fortunate enough to have worked for HashiCorp for the last 4.5 years. I am now the primary lead for the relationship with Microsoft globally, based out of APAC, but doing a global role, and get to work with great folks at Microsoft across the world, figuring out challenges around how to solve customer problems. Next slide, please. So just to put a little bit of construct around the relationship with Microsoft and to understand where HashiCorp fits in. We were built, or our founders were started in 2012, which were they were working at the core element in Seattle where cloud was being fundamentally built. So they were fortunate enough to be involved in a lot of that early development, and as part of that, they have had strong relationships with working with Microsoft ever since. We have been fortunate enough to be the recipient of the Open Source Azure Partner of the Year in 2021. We were the US finalist for Open Source last year. We were also a nominee for a Global ISV Award. So we've had a strong relationship with Microsoft. That relationship has led to joint engineering. So our provider, so our mechanism that talks to the API, that in this API first world, has a joint engineering collaboration between both Microsoft and HashiCorp. Our engineering teams talk regularly and have worked together closely to get new resources in as soon as possible. We've now come up with mechanisms to actually do a lot of that automatically. There's a stronger development together and working very clearly to go together to create this strong engineering force. From an impact perspective, HashiCorp is very fortunate in that we are involved with, and as Francois said, we've been doing a lot with the cloud. We are synonymous with delivering the cloud, and that means that we are in a lot of the top 2,000 customers. And that means that we actually, as a small ISV, we actually have a lot more influence than it's probably right for us to be at this time in our early development. But we have been involved in a lot of things, and this means that we are seeing things like 100 million annual downloads. We've got 12,000 dev contributors to our open source projects, which means that we get all of that brilliant open source community development work going into our products to help us be better. Loads of active community, loads of support. And so this position, next slide, please. This position means that when we go to, next slide, please. Thank you. When we go to have a conversation with our customers, we can go out and we can talk to customers that are actually influencing and doing a lot in the cloud. And we get to see some really interesting things and trends when we go and have those conversations. We had been doing it for a while, but a couple of years ago, we formalized this into our State of the Cloud survey. That survey was something, and it's downloadable from our website. That was a conversation that went out to the customers and said, what are the key things that you're looking to try and achieve? What are you struggling with? How could we potentially help you in these areas? And the three things that came back, which speaks exactly to what Jason was saying, is, how do we get time to market? How do we improve that time to market? How do we actually establish and work with security and governance compliance for our business, meet our business and risk compliance components, which is starting this thinking around how do we get policy as code, and starting to then also think about this, how can we do more with less? So this operational efficiency, the ability to actually be able to punch well above our weight in terms of the amount of staff that we have and the ability to actually deploy a large scale set of resources. And this is becoming even more true, obviously, with the current financial climate. And as we start to think about how that we can scale out the cloud adoption across more mainstream organizations and to get larger usage and adoption of the cloud. So having that operational efficiency in place is essential. And so to solve this, there are key elements that we will talk about as I go through this presentation that touch on these key areas. The one that I just want to talk about here a little bit is that time to market, and thinking about that construct where, from a banking organization, from a kind of scenario, is banks used to have the battle of the high street. Banks used to be very much around who could get into the high street, who could have the most branches open, who could get to their customers and be most readily available to their customers to win that battle of the banks. But that isn't true anymore, right? They're closing down, you know, high street retail banking left, right, and centre, saving costs, looking at how to streamline that. Battle has now moved onto who has the best application, who has the best features and functions, has the best ability to engage their customers from an online or smartphone perspective. And so if you think about a traditional bricks and mortar business, and very traditional in their thinking, like banks, very risk averse, are now fighting that battleground online and having to think about how they can be agile. And as Jason mentioned, that thinking about that agile development. When I was working, you know, for an organization here, a banking organization here, we had 2 releases a year because it took 6 months to actually prep and do all of the changes. Now that obviously isn't going to win you that battle of the banks if you're moving that slowly and need to add smoother changes at that time. So how do they become faster? How do they become more agile? And this strikes a challenge. Next slide, please. This challenge is, how do we strike this balance between the agility that we need, so that time to market, the flexibility, the inspiration that cloud has shown through being proven to be quick and agile and getting a quick ROI return for a quick ROI for the effort put in, and striking that balance against how do we actually scale this? How do we put this out with safety rails in place that the whole organization can adopt it? People without the necessary understanding of the cloud skills can use it, and we can do that in a very safe and secure way. And so when we think about how cloud was traditionally built, particularly the early adopters, you usually had a COE team, so you had a small scale team, probably had a very high level of knowledge, knew particular services as they were brought on intimately well, knew how to configure them, knew how to do that, worked as a small team, and usually shared code within that small group, which is fine at that scale. But as we then think about how do we build this out and move this into a larger adoption, how do we move this into new customers, how do we move this into adopting in a new framework at scale? So you can't have that small group and that high level of knowledge. You need to have more policy-based control. You need to have a set of standards that you can comply to. Risk and compliance around the overall business needs to be brought in. And so this is the conundrum that we are looking to try and strive and achieve as we work through this presentation. And so that's a key thing just to keep in mind. And as we go through, we'll be looking at how we can possibly solve some of those challenges. Next slide, please. And so when I was looking and doing some reading around getting ready for this presentation, one of the things that I came into my inbox was this defense report from Microsoft. And I think it's a really good asset. If you haven't seen it, you can sign up for it. And in it struck me, and this number really struck me, as 98% of attacks can be addressed using basic security hygiene. And that element to me really kind of resonated in that a lot of the knowledge that is already established, a lot of the best practices, a lot of the understanding things like leveraging the well-architected frameworks, tools and tooling that are built into those to do assessments, using the cloud adoption framework if you're looking to actually accept and build out and just starting to move into the cloud and starting to do that whole people process change component. Using those best practices and established techniques, using those, in some cases, codified modules, can actually help you cover 98% of that attack platform. And so thinking around how you can apply already established patterns, already established knowledge to actually apply best practices to your cloud is going to, from a kind of home owner's perspective, you're going to lock all the doors and windows before you start to think about how do you put in a burglar alarm. So it's just going to create that grounding foundation around your security to actually put you in the right place to then fine tune that with other tools and mechanisms that to actually help that, such as Defender maybe. And I think there is a really shared thinking around this HashiCorp and Microsoft vision around how we can improve the security, not just in the cloud, but also across the cloud and actually into a hybrid scenario, which is where we can start to really show HashiCorp adding value into that Microsoft partnership and relationship. Next slide, please. And so Jason kind of touched on this. In the Microsoft DevOps component, obviously there are large set of elements in thinking about how you create and start your DevOps workflow. There are different components in that. Obviously you need training, you're going to need people skills, compliancy elements, and different elements within setting up your overall pipeline and workflow. And so within all of these constructs, how can HashiCorp actually help and fit in? Next slide, please. And this calls out exactly where HashiCorp really does fit into that. So when we think about, or when organizations think about HashiCorp, they think about tooling, they think about automation. We have well-established products that we'll talk about in a little bit around where we fit into this automation stage, and also then adding value and help around keeping secrets safe. And so when we think about what we're trying to achieve, HashiCorp is part of the process. We're an organization that will help you fit in and create the necessary tools that will build and help you support the workflows that will set up your overall DevOps scenario to actually help you get there. And so with that, we can talk about some of those tools. So next slide, please. And so this is our product set. And so the way that we think about our product set is we divided them into 4 categories. We have our infrastructure. So in that automation space, into that tooling around how do we help actually start and build. We have Packer, which is our image builder. That is a known image creation used across multiple platforms to actually set up and build SOEs. So for example, you could create an image that is going to give you a Sentinel agent embedded into that when it stands up. So now when any of your images are pulled, it has the right the right elements within it and the necessary configuration to immediately start talking to your Sentinel and your SIEM. So now you've already built part of that control mechanism. So again, sprinkling that little bit of security into your automation thinking. So Terraform is our infrastructure as code tool. It has been widely adopted as a pseudo standard for infrastructure as code across multiple clouds. It can even work with on-premise components. So we can drive Cisco firewalls, load balancers, different partner things. We work with SaaS products. So I know some of the SaaS products that have already been on here. We can help drive all of those things. So now you can codify not just my platform that I'm wanting to create, but also the overarching elements that need to support it. So now you have a real as code approach to everything. And the way that we think about that is we integrate that as code approach with all of these tool sets. So Terraform can be used to deploy console and Vault, Boundary, and so forth. And so as we move up the stack, we have networking. So how we connect that, we use our service mesh tool, which is console. And then as we move into security, we have Boundary and Vault. So Boundary is a newer project, which is focused around end user access. And Vault is about identity brokering and identity managing around secrets and key management. So when we talk about where we fit in, these are kind of our security tools that we'll be based around. And starting to think about how that fits into creating a zero trust construct, which we'll talk about a little bit further. And then in the application space, we have Nomad, Waypoint, and Vagrant, which allow you to then do scheduling and application deployments. Next slide, please. And so HashiCorp is purpose built to become a platform component for creating your infrastructure as code. We work closely with Microsoft, as I said, and we integrate with a lot of their tools to actually help create that overarching deployment and simplify the actual deployment components, which we'll take a look at. So integration, for example, into Azure AD. Leveraging that to set up the identity and control. So now we're starting to create the right level of privileges and control and constraints around who can actually access your infrastructure. We've integrated Terraform recently in with OIDC so that Terraform Cloud and Terraform Enterprise now can be used and integrated and set up that dynamically, pulling credentials in to give the least privileges for a plan or a place. So as we either plan to set infrastructure or plan to build it. We can do granular control with based around those roles. And then an important one is obviously because Terraform is a declarative language, we can manage and understand what has been deployed and can make adds, moves and changes to that existing infrastructure because we have a state file for it. We understand what's being declared. That needs to be encrypted. And so taking on that management, taking on how to do that, obviously, again, meeting that challenge of encrypting data at rest and taking on that burden of having to manage that as part of your tooling. So again, thinking about how we can simplify the delivery and simplify that overarching platform integration. Next slide, please. So Jason kind of touched on this, and I just wanted to expand on it a little bit. In terms of waterfall, this is kind of what that waterfall process is talking about and thinking about, in that you had a starting point, and in this case you have a developer who goes, ta-da, I've created this new view, best application ever, and I need to get that in front of the customers as soon as possible. He then created an ITIL ticket usually and push that out. That would then go to probably a database or maybe a networking team or compute team in this case. They would then start and spin up the necessary elements that were within their domain and they had access to. That ticket then got closed and maybe another one subsequently opened and passed on to the next part of the team, and so on and so on and so on, as it fell through the different stages of deployment until it was actually then signed off and went live. This obviously takes a large amount of time just in the ticket handling, let alone the actual tasks to actually do that. Whether the tasks are manual or automated, this would actually slow down the overall arching construct. You know, if someone finishes just on 5 o'clock, as it passes to the next person, maybe they say, well, I'll wait and pick that ticket up to the next day. You've already wasted all of that time. So next slide, please. And so where automation fits into this and where Terraform as a key part of the player in that platform of creating automation fits in is becoming the interface into this API first world, where we shrink down that opportunity. The developer writes the code, they create and have a single source of truth that we'll look at, and then use that to actually deploy and steer traffic out to the individual teams and deploy that infrastructure. And those teams can actually, because they can take this as code approach, can preempt and write modules or deployable, repeatable code sets that actually solves the needs for that developer. So now you have an ability to actually create content or code that could be used to achieve that specific task that the developer can actually look at. And this is where that value proposition really comes into when we think about the CAF modules, for example. The CAF modules are available on HashiCorp's registry. So as a module registry, you can go to them, download them, use them. You have a usable source, again, with that best practices built into them. So now we're getting that sprinkle or side of security, again, added into what we're trying to achieve. And now as you deploy, you know you're building to best practices. You can take those modules and obviously adapt them. You could build your own version of that model. You can get them vetted and passed by security, risk and compliance beforehand. So now you're starting to streamline that process and create boundaries around what we're doing. So if we think about that, next slide, please. If we think about that and how that changes the process, we can now see that automation is the key to unlocking that complexity around scale. And as we think about scale, we go through this loop of developing, planning, running, provisioning, and testing. And I think this is a key part of around that thinking of that, where that DevOps process starts to actually see the shift left. So this construct of shifting where we actually apply security to the left. So to the first stage of our traditional left to right writing stanza, we're shifting it to the far point so that as developers start to create their content, they are starting to think about what tests need to be done and validated to actually get through that process. So we're taking what would be automated above, we're simplifying that down, and we're starting to actually use in this case, GitHub, for example, of the version control, where we're creating a single source of truth that our developers write to. That can take actions and testing plans, pass that through and actually drive the infrastructure component to actually drive policies to stand up that infrastructure. Next slide, please. In a more complex scenario, and we start to think about all of the tooling, so obviously Hashi is very known for Vault, but for console and Vault. But where we start to think and really expand this is when we start to put those product sets together to create a delivery mechanism. So now, if we take that scenario where we said that, you know, automation is key to unlocking that complexity, we now think about, right, now how are we going to deploy this at a large scale across our organization? And so we take our CAF landing zone that we created, for example, or Azure landing zone, maybe it's even our account factory that we're looking to actually establish our subscriptions and the necessary components within those subscriptions. And we want to stamp that out across our different business groups as they start to apply to this. That is stored in a version control. We have created Sentinel policies, just to be really confusing. HashiCorp has its Sentinel, Microsoft has its Sentinel. Our Sentinel is the policy as code engine that we use. It also can use open policy agents, so OPA, to create policies around what the infrastructure can do. So now when you're looking at this infrastructure, you take that standard, you make sure it has policies and compliant to the risk and environment that you need, whether that's something as simple as having the necessary tags for the environment, or whether it's something as complex as going down and looking at instance sizes or container versions that are being used and making sure that the right ones are enforced. When it passes all of those things, our app code is then added into that trigger from the developers that are creating it. We have our base, we have our application code that triggers a deployment. It runs through into our platform. So now we're starting to use that platform thinking where Terraform Cloud can actually run this. As I said, it's got the integration into using OIDC. Done it wrong way around again. Open Connect is the easiest way to go, and get the least amount of privileges needed to actually run and stand up the infrastructure. As it does that and starts to build, so we can pull secrets dynamically from Vault. So not only if we think about that earlier image where we had a SOE with the right agent embedded into it, if that machine needs to gain access to a database, for example, from an existing on-premise component, we can inject a dynamic secret into that as part of that run and stand up. And so now that image is has the least amount of privileges to be built. When it stands up, it has a dynamically created time-dependent access code to go and access the database. It establishes that connection, gets the information it needs, and then that credential is then dynamically timed out. If it needs to use it again, it will go back to HashiCorp Vault and dynamically request another one. And that is also based on identity. So you actually need to authenticate who you are as that application to actually understand that criteria. Next slide, please. Which leads us into identity being a key part into the zero trust approach. And so why zero trust, or what is zero trust? Well, zero trust is this move away from the traditional security components into which is when I started is a firewall, perimeter, lots of subdomains within it, lots of tiered firewall policy decisions into an identity-based construct. And so because Vault, HashiCorp Vault, uses identity as a pretext to actually understand who is doing what and making what requests, and then we apply endpoint security and policies to say, well, that we know who that person is and we identified them and they're allowed to do this single thing. We now have identity being the key driver around our access policy. Next slide, please. And so when we think about what where that fits in, that application or legacy identity was based around different criteria. So you had your application identity, you had your network identity, and you had your user-defined identities, which was usually associated with a login or password in some way. And so where we have moved to and why we have moved is as obviously you move to the cloud. So all of these elements used to be built within your data centers. And so having control and construct with around all of these elements, you could manage them. You could control them. You could build policies around them. You knew what the endpoints were. You knew what the applications were. You had internal DNS names for most of these services. So even if they changed a little bit, you could still resolve where they were. And so a lot of the policies, and I know from my own time as firewall management, there was hundreds and hundreds of policies built around IP based and domain to domain, so known subnet areas. Obviously, as you start to move into the public cloud, this becomes unattainable and unachievable, right? You don't have that level of control. Subnets overlap. Subnets are external, some are internal, some are accessed over the public internet, some are accessed through private links. They're all different levels of control. And so now this becomes a real challenge. Next slide, please. So when we break that down, you can see that identity, adding in cloud, creating users, we've now created these all of these different constructs that we need to actually understand and achieve security through. So how do we do this, and what is common across all of these different elements? And that is where identity fits in, because you can identify an application, a machine in a network, a user, and a cloud component. So and use that as a source of truth. Next slide, please. And so when we think about where we fit into this, and HashiCorp fits in, is adding in this simplification across platform. And I think that's a really common question that I get asked from a lot of Microsoft partners and customers is, well, isn't there already services that kind of do this? Well, there are, and they're good starting points. Most of that is based around static construct, whereas Vault is really looking at how we can do that dynamically, but it's also around how you do that dynamically across multiple platforms. Now, whether that is in an application space around modern containers and containerized across multiple containerized environments, and you're using HashiCorp's Vault as a common secret store so that those applications can actually talk across one another and have the right level of access and identity as defined by a single policy, but still have the control to be able to cut the drawstrings, to cut them off or shut them down if you think there is a risk or a breach. Having that ability to identify different networks, so that could be an on-premise component and a machine on-premise and a machine in a different data center, whether that is a traditional user type access or whether that is now part of the cloud and where I'm connecting and what that cloud is based on. We can help broker and create using identity and a trusted source that we can identify to. So Azure AD is a great example of backing into that to create that repository. We can then broker those secrets and we manage those secrets around a TTL, so a time to live that actually can dynamically control how long and automatically renew. So if for any reason those secrets need to be renewed, you can force them, but as a best practice you can set the minimum viable time for that entity to then have an authentication. So the secret is only valid for a very specific period of time and is least permission specific. So now if it does become compromised and a bad actor does manage to get a copy of it, it's only going to be valid for a very short period of time. And so now for them to get to the next stage of their progress, because despite movies like The Matrix and things building these wonderful stories around what hacking looks like, we know that in reality it is a long and slow process to move through and get to the prize or capture the flag. So all of these things make this harder and harder for those bad actors to do. Next slide, please. And so in the application space, Vault becomes this key identity broker. And so it can be used for both identifying or taking traditional user access, network access, application space access, and using it to actually broker identity. So in an applications perspective, it can use something like a JWT or even a certificate to then say, this is who I am, go and authenticate against Vault, get the permissions. So we give back a token saying, we know who you are, we now trust who you are, you're a valid user. Here is a token for you to ask for what you need. That token then allows that application to then go and ask for a database credential, which can be dynamically created and written into Azure SQL, for example. And now that application goes and asks dynamically and has a username and password that is only valid for the time that has been created for, and we remove it afterwards. So you get this rotation of passwords automatically happen. There's no hard-coded applications. There are no post-it notes stuck on people's PCs when they're creating applications around writing those down and statically configuring components. Next slide, please. And so as this moves into then building out, well, how do we then secure this across those network components? So this is where console and our service mesh comes in. The service mesh component of this takes the necessity and dynamicness of a multi-cloud environment or a hybrid cloud environment, becomes a service discovery tool, finds those applications and registers them automatically, and then allows them to be securely connected either within a containerized environment or from external. So it doesn't have to actually necessarily be a container, but can still find them and create them into part of the service mesh, and then establish policies based on what those services are. So the front end, it can have a component where it can only talk to a web tier, maybe, for example, or and the web tier can only talk to the back end. And you can set those reasonably broad service-based policies, but capture very specific elements. And so if something does get compromised, it makes it very hard to then jump between those services. Next slide, please. And I think this is probably, when we talk about identity and we talk about identity management, this is where most people do think about immediately their mind goes to is the traditional user access. Most people think about identity control, username, password, how do we secure that? And so in that space, the collaboration of Boundary, which is a remote access tool to be able to allow and provide privileged access to resources that are being dynamically created. It understands and can understand what services are being brought up using something like console and a dynamic DNS, linking that into Vault to get dynamic secrets into it. So now as your user has to validate who they are to get access, Boundary will know where those resources are and have been deployed, even though they're dynamic, and will create dynamic access and passwords that are only valid for that session time. And so now we've simplified that remote element if users need to get in for whatever reason onto a device. And so all of these things go together. Next slide, please. To kind of go together to work as part of, and I emphasize as part of, the zero trust thinking. And so zero trust is this element that fits into all these different criteria, and HashiCorp is a key part in being able to help you meet those different areas. In that, we can help reduce the attack surface. So in that initial access with, particularly from a user perspective or human access, you have Vault and Boundary limiting that control. You have then, because of leveraging something like Vault, privileged escalation control. You're only providing the least amount of access necessary for a dynamic period of time. So access is very limited, and for them to compromise it is only valid for a particular period of time. You then have credentials that have been also expired on databases and other elements, and then lateral movement between those different services obviously is secured as part of that service mesh. So helping reduce that attack surface, making it very hard for a bad actor to actually gain gain the initial foothold, but once they have, if they do get a foothold, trying to move between those different devices at different hot points to get to the prize. And if they do, making sure that everything that is passes through the network is obviously encrypted as from a end-to-end point. So making it very difficult to try, or just making it even more difficult to try and get anything out of your network. Next slide, please. So what does this look like practically? So next slide. What I wanted to do was just kind of go back to our thinking. So now we have our automation. We've established that automation is key to being able to do this. We have our developers writing our code right into a version control component. They are looking to use API first. They're looking to do short-lived workloads, immutable stood up. They're looking to provision with purely with code, so taking an as code approach, and looking to actually do this on a multiple times per day, per week, per hour. Next slide, please. And so the first part of this is obviously starting to create that integration with Terraform, where we have our version control. We have different access. We have different access points to suit how people want to use it. So in our case, we're looking at version control because we're trying to have multiple users do that. It could be in a more traditional way with an ITSM and something like ServiceNow. So it's an API-driven workflow where you start to have service catalogs and self-service components. But all of those actually feed into, in this case, Terraform Cloud or Terraform Enterprise. You have the policy and control using SSO and who can do what to that infrastructure. They're triggered and that kicks off the build of the workloads into the necessary environments. Next slide, please. In that environment, we now expand this to think that our developers have made that code, they committed it into GitHub, it kicks off a pipeline build, our infrastructure has now been pulled in. We have our private module registry, as we talked about before, where we have our CAF modules that have our best practices and security components added in. We have a plan that is speculative, so it goes out to maybe as part of a run task assessment out to a third party to be assessed to see if there's any vulnerability. So getting in that scanning and that thinking around how we can validate and test as soon as possible. We enforce that only the right modules can actually be used in terms of by using our HashiCorp Sentinel policy to make sure that the right modules are not, potentially malicious code modules have been used. That pulls in a standard image build that we've built with Packer to actually have our Sentinel agent embedded into that. It has a dynamic secret that's pulled out of Vault to allow it to get access to a database, and then the final configuration components are done using a configuration management tool, all based on the Azure platform and giving you that flexibility to really automate that deployment. Now around this, you can then also tie in things like deploying Defender using Terraform as well. So there's a great Learn article, for example, that walks through this, where this is just establishing the infrastructure components, but you can also use this same thinking to start establishing the security deployments into that. So one of those modules may be a standard security module that stands up Defender and Sentinel and a whole different array of detection elements within your environment. So now you're again thinking about getting that automation and security coming together to solve that challenge and doing it in an automatic way. Next slide, please. So what bits do we really need to consider to start trying to get this together? Next slide, please. So this kind of sums up what we've talked about. We've got the developers, we've got a version control system, we are doing regular pull requests or push commits into our code base. Those trigger builds, that trigger that is built is done through either GitHub Actions, adding in things like security from integration with HashiCorp's Vault to pull in that dynamic secrets. We have then last mile, I was going to say, so my telco telco age. We have the last part of the configuration around, standing up Kubernetes environments. You can use Terraform as well to actually even integrate with full CRUD updates for applications within Kubernetes. So again, your application deployment, you can use Helm charts. You can stand up all of this environment and apply security into that element around dynamic secrets, dynamic access. If you do into Kubernetes, you can Vault can be used as a secrets management store, and also authenticates directly into it. So again, you have this single approach, and stand up all of these things using a as code approach. So everything can be codified. You can write and create your Terraform workspaces using Terraform. So now you can automate this whole process. Next slide, please. We spoke about GitHub Actions, and I just wanted to highlight kind of this as an example. You can see here how simple it really is. So with a few lines within our GitHub Actions, we have got a token that we use from this from the Action Secret Store, which uses to actually validate and go and talk to HashiCorp Vault. HashiCorp Vault can then has an endpoint. We go and pull a secret from that endpoint. In this case, we do then a substitution into that Docker build and substitute in a dynamic secret in this case. So it doesn't take a lot to be able to integrate this into your actual workflows and pipelines. So those few lines of code and those few elements, there is a whole set of examples on the HashiCorp developer site around and a repo that shows all of the GitHub examples that you can just basically lift and use to start integrating this into your pipeline deployments. Next slide, please. Obviously, proof of the pudding is always in customer use cases. And I think this is obviously a great example. GitHub is a customer of ours. They are a reference customer that we have worked with. Hopefully everybody in here should know who GitHub is, and being part of the Microsoft community. Next slide, please. We have done a lot to work with them around helping solve a few of those challenges. So they did need to be able to support a multi-cloud and multi-platform environment. They had to look at a way to be able to efficiently bring on and onboard and train developers. So they used that industry knowledge around Terraform and a lot of the products to reduce and actually expand and reduce the overall time that developers needed to learn tools, because there was a common set of tools that they already knew and understood. They integrated and used service discovery and service management to simplify bringing up and engaging those new services across hundreds, if not thousands, of servers and nodes. So again, that simplification. And then and when we think back to those challenges, this is now that operational efficiency. We've got our security and regulatory compliance and our time to market. And as a benefit, we also had a reduced amount of load balancers and a reduced amount of configuration time using console, which has its own built-in envoy proxy or uses the envoy proxy. So has that simplification of the load balancer component. Next slide, please. And so a couple of things to go and as actions to go and do, and hopefully will be some collateral that will be useful to you. There is a joint ebook between HashiCorp and Microsoft that goes into a lot of the concepts that I talked about, goes into some of them probably in a more articulate way than I framed it, but also having that knowledge in an ebook to be able to reference and use as well. So that is a great resource. Next slide, please. And then there is a series of webinars. We recently, last week we ran our first series in the security and Azure Microsoft and HashiCorp series. There is another one coming up. Go subscribe and see the events. These are joint speakers between Microsoft and ourselves. So we do actually get Microsoft speakers in there and we cover off a whole range of elements. Next slide, please. And that's me done. So I will open this up to the Q&A section, and hopefully we have some great questions, and if I will do my best to answer all of the ones I can, and if not, I will get back to you with answers for those I can't.
Thanks a lot, David. Maybe for me to ask you questions. First is, you went through the automations and so on. Is there things where you feel like we are still a challenge to automate so far, or how is it going? I'm thinking of, for example, policies, policies or certain scenarios, like if we want to do some rollbacks.
So some of the things that are obviously a challenge, which are getting better, is that there are still, I mean, fundamentally, there are still service gaps around the API. So we moved to using the Grapher API. That API we have a lot of services, and we've now automated the discovery of all the new endpoints as they come in. So we're starting to actually automate that and get a fuller repository of the services, but there are still gaps, to be fair. And this doesn't speak to then any of things like GovCloud or any of the secure cloud or unique cloud endpoints, which then create other challenges as well. So organizations are looking to then use those custom clouds, then probably will come into some challenges, not from that it doesn't work with it, in the fact that those endpoints are different, and therefore we can't actually communicate to the right graph endpoint. And so there has seen challenges, particularly with federated and local government around that. That's a challenge. I think you're right. Policies and policy. I had a really good question from a customer today around, well, I've got to do a policy for this, and then you're talking about Sentinel policies, and then I use my OPA policies, and then I've got, and that isn't, that's a challenge. That is a challenge, and partly some of the value around where partners and cloud professionals can actually add their value is in sorting out those challenges and having an understanding. We've tried to make it easier by moving to use OPA as well. So having, again, a community base in the HashiCorp registry, there is a section now on Sentinel and OPA policies. So that, again, that community knowledge of, I wrote this policy to do X, that is starting to be seen, and people contributing back to that registry. So in some cases, the policies are there for you. So there are attempts to try and simplify this, and I think as we get better, as the functionality with the endpoints and communication with some of the driving the policy things, for example, so things will become easier. You can always use AZ API to actually drive an ARM template or a remote endpoint to get what you need. So there are ways and challenges to do it, but it just comes down to then it's not as simple and not as repeatable as it probably should be. And then that is it's a challenge. It's something that is definitely being worked at. So
okay, and maybe you mentioned AZ API.
Yeah,
that's a question also we get quite a lot. Is between, so-called the original Azure RM provider, now with AZ API. Can you share, do you have any best practice to share on when to choose one provider or the next?
Yeah. From a personal perspective, I would use Azure RM as much as possible. I think AZ API is a mechanism that allows us to fill that gap. So that challenge that I spoke of in terms of, I need this service and I can't get it because it's not built into Azure RM yet, or it's a brand new feature and it's beta, and I don't want to add that into my providers to break anything, because I don't want to go to an experimental version. Then you can use Azure API. So I had a question recently around ARO. How do I do ARO deployments? And that is all based around Azure API. And so you can still get there, you can do things. Obviously, it doesn't have the built-in elements that you would expect with some of the Azure RM modules. So things like data sources and some of those action points, because that is the value of Terraform, putting in that logic into understanding what those endpoints are and feed in the back. But it doesn't mean that you can't use it and get things done. From my perspective, it would always be go to Azure RM first. Can I get it? Is the features and functionality there? Even if there's 90%, and then I just use the last 5% to do the one or two things that either there isn't an endpoint for, or there isn't a feature or function or service endpoint yet available.
Okay. I mean, that's all for me. Thanks a lot, Jason. Maybe you might have more questions for our presenter today.
I think you're on mute, Jace.
Yeah, I think you've asked the question that I always wanted to ask. I'm also a user for Terraform. When AZ API came out, it was like a beacon of hope. I mean, I always wanted to try the new features, right? Then we always see that RM is not there. Then we always like, okay, we have to wait, right? I mean, with that AZ API, we can now at least try and see how can we incorporate some of the newer changes. So that is really exciting to see. So I think my question is more towards like on top of my mind as a developer is always about support, right? So I just want to understand a bit from your perspective, how does that close collaboration between Microsoft and HashiCorp in terms of the engineering and the support, just to give our audience a bit of the insights. Yeah.
So I think support immediately strikes up an interesting challenge. because support means many things to many people, and their expectation of what support is can range from, I expect professional services to come and build this for me because I can't do it, through to here's a clearly written bug report and I just need you to fix it. I think if we talk about where I think the elephant in the room is from a tool perspective is a lot of the users are using Terraform open source, and so from that perspective, from HashiCorp's perspective, they are community users, and so they fall into the community support bucket, even though they are then an enterprise customer doing an enterprise grade migration with you guys, for example, and so. The expectation is from our side is, well, you're on an open source platform, and we do best. And there's a developer team. They do a really great, outstanding job around. And I talk to and work with those guys a lot. But obviously, being an open source and community based, there you can imagine there's a list of issues that's about this long, and they have to chip away with them. There's no real kind of customer enterprise priority or support. If they are a HashiCorp customer, so they're a cloud or a enterprise customer, that then does at least give them a channel in directly from us as a supportable mechanism. And within that, there's quite a lot of support that can even go down to, and I know a lot of our support guys are budding developers, because they will say, well, you've actually made this mistake on your code, or if you do this, it will actually work. And so there's quite a large support that way. If they are using and are deeply rooted in just an open source element, I have seen it where these issues can be raised up through Microsoft support or through Microsoft CSAs. There is an internal mechanism and escalation that I'm across. So I work on the internal. We have a bi-weekly meeting internally called Terraform Tuesdays. That mechanism is open to everyone globally. They can bring customer issues to that, and they get worked through at least with some form of priority, even if they are an open source. So from a CSA perspective, I've tried to do this. I've tried my best. I want some sort of visibility into that, and there is mechanisms again around that joint collaboration to try and make it more seamless for the customer. But that's the main challenge with support, is not so much it's not supported. It's well, they've done all of this work with community, but people seem to then think that community is a full enterprise version and should have full enterprise level support criteria. And that's, so sometimes it's more about expectation on what that means than it is actually managing the issue, I would say. One thing as well that I just want to kind of reconfirm is with the AZ API, and you're saying about getting early access to services, there is a project that is actually being worked on and is currently going through where we've automated that discovery, and that was a joint engineering project between Microsoft and HashiCorp to actually make sure that we can now effectively crawl and understand and write those swaggers automatically in, so that there is day zero support for that in Azure RM for new services. So, or not, sorry, I was scolded for saying day zero. Day one, they want to say, because it takes them a while to discover it and then they add it in. But very early adoption into their thing. So some of the problems that we have seen, if you go into the Git issues where I need this feature and it's been open for 6 months, a year, that's being addressed, and hopefully by the end of the year, early part of next year, we will have a lot closer parity around that. And so the challenges of which one do I need and how can I do that will be to be solved.
Okay, cool. Thanks for the answer.
Yep. Thanks, David. Before we wrap up, just maybe a reminder from my end that, as I said in the introduction, we have more sessions coming in coming weeks. So please register if you haven't done so. Otherwise, we are very keen to hear your feedback, right? So what went well, or what can we change to improve? So please submit your feedback as much as possible. Thanks a lot, everyone, for joining us today. Thanks, David and Jason, for being with us.